Hello, guys. It's Mrs.Z again. This is lesson 10 word problem, and it is grade 5, mission 6, lesson 10. Okay, let's read it. Word problem. 12 men relay team runs 45 kilometers race. So 12 men are run 45 kilometer race. Each member of the team runs equal distance. How many kilometers does each team member run? One lap around the track is 0.75 kilometers or 0.75 kilometers. How many laps does each team member run during the race? So we have two questions to answer. We have this question right here and then this question. So we need to focus on one at a time, and then we're gonna reread the story and think about what kind of story is this, what kind of word problem is. 12 men relay team runs 45-kilometer race. Each member of the team runs equal distance. When it's equal distance, it means the groups are the same, equal. So that tells us that this is a multiplicative problem. And we know how many groups, how many people are there, but we don't know how size of how much did each of them run. And we know the total or product that is 45 kilometers. So if we look this problem, we can say that is 12 times the question mark equals 45. So we know 12 people times how long each person will run will give us 45 kilometers. This is called semantic equation. If we're gonna solve it, we needed to use and do division. So what we need to do is 45 divide in a groups of 12 will give us the how many of each is. All right. So now when we draw a picture of it, we could think about this. Let's make open rectangle, because this tape diagram will represent the people that we are involved. So we know that there is 12 men. So we're gonna go, and if I go and draw a line here, that's 1 man, 2, 3, 4, 5, 6. You see, I can keep going. If I have an open rectangle, I can keep adding lines and see 1, 2, 3, 4, 5, 6. And I'm trying to make it 7, 8, 9. I need more. About maybe this much, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then last one would be 12. So open rectangle is good if you needed to make, yes, equal spaces. About, so now this represents 12 12 men. Okay, they all run 45 kilometers. 45 kilometers. But what we don't know is the size of how much each member ran. So this is our unknown. That's why we needed to divide 45 with 12 to find the size of the how much each ran. Okay, so if we do standard algorithm, we can think how many 12s are in a 45. Okay, so if we do this 45 and 12, our group is 12. How many 12s are in a 45? We can add 12, that's one group. If I add one more, that would be two groups, that's 24. If I add 12 more, that would be 36. Okay, so I do have, if I add 12 more, it will be above the 45, but it would be 48. So I can add another group. So in 45, we have three groups of 12. So that's the three groups of 12. And then 3 times 12 is really 36. So minus 36. Now, we needed to subtract. We cannot give away 6 if we have 5. So we have to regroup the 10 in order to have more ones. So this is going to be 3. And 5 plus 10 will make 15. So now we can use the strategy of think addition to subtract. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we open 9 fingers. So 9 plus 6 make 15. So counting from 6 to 9, to 6 to 15, it'll give you 15 minus 6 as well. So that's 3/10 minus 3/10. There is a 9 left. So that means this is, we're going to show as a fraction. So our answer would be 3 and 9 twelfths. Would be 3 and 9 twelfths of kilometer will each of these people ran. But we also gonna simplify that so we can see if we have 3 and 9 twelfths. Greatest common factor means the number that we can divide both by, and that would be a 3. So if I divide that, I will get 3. 9 divided by 3 is 3. And 12 divided by 3 is 4, because 4 times 3 is 12, and 3 times 3 is 9. So the final answer, that is that our question mark is 3 whole kilometers, and 3/4 of the next kilometer will each friend ran, each man ran. So that's we got our answer. So here was the question mark, like one man run. So that was question mark, and that is 3 3/4 kilo. Not kilogram, kilometers. Sorry, guys. cm, kilometers. So this is mistake, right? Kilometers. We just answered question 1, but that was how many kilometers does each team member run? So we can answer in writing. Each member Each member ran 3 3/4 kilometers. So now, what the second question says, how many laps does each team member run during the race? Because a lap is not whole kilometers. This is information. One lap around the track is 0.75 kilometers. When you think this, 0.75 kilometers is 1L, lap. I call lap. Okay, I can write it down, lap, right? So we can also see this as this is 3/4 of a kilometer. We can think about this to be 3/4 of kilometers equals 1 lap. That we can see. So this problem could be solved in a different way. We can think about now that how many 3 3/4 how many of these 3/4 are in this. So how many laps are in a 3 whole kilometers and 3/4 of a kilometer? So there's different approach to it. Mathematically, you can say, okay, 3 3/4 divided in a groups of 0.75 or 3/4. Okay, 0. We can also 3/4, or if we change this into decimal and this into decimal, then we can also see that same problem could be solved by the 3/4 is 0.75. So it would be 3.75 divided into groups of 0.75. So if you want to do the standard algorithm, you can think about how you can multiply this decimal by 100. So then you will have your problem will be solved by 375 divided into 75. That's one approach. The other approach is if you change these 3 holes into parts, into the fourths. So you have all fourths and you group them into groups of 3/4 groups. I think it would be valuable if we show both approaches. So let's see if you have, let's have these, let me see if I have the circle. I will do that. Okay, I'm going to use my tool to recreate 3 holes. 1 hole, 2 holes, 3 whole kilometers. And then I also have 3/4 of the neck. So I'm going to kind of do this way and have a center. So I can do whole circles. Okay. 3 3/4 would not be a 4 holes. But because our fractions are fourths, I'm going to cut now. This is, if I cut in it, this represents the 3/4. 1, 2, 3/4. So 1/4, 1/4, and 1/4. That represents 3/4. And that is 1 lap. So 3 holes and 3/4 is represent this. Now I'm going to divide them in groups of 3/4. So here is 1 3/4. That makes 1 lap. Okay, and in changing these three holes into the fourths, you decompose whole mile into the fourths. Okay, so now each mile is cut in a fourth, and then 1/4, 2/4, 3/4. This will represent also one lap. Okay, here is the one lap. Okay, one lap. Okay, now this fourth and these 2/4 will represent another lap. I'm going to use the pink highlighter, so 1/4, 2/4, 3/4. That represents another lap. Okay, now again 1/4, 1/4, and 1/4. These 3/4 on the next lap. And the last three is 1/4, 1/4, 1/4. That will represent one more lap. So each of these people, they actually they ran 1, 2, 3, 4, 5 laps. So 3 and 3/4 kilometers will represent 5 laps. So that's what one approach to. So we can write each team member ran 5 laps. That's one way. If we think about changing these 3 wholes and 3/4 into decimal and do the algorithm, we needed to think that this is decimal. When you divide, you have to have here the whole number. You can logically, I'm thinking like you can divide something in 0.75 groups. It has to be the whole groups that you could divide the number into it. So by that, you need to actually get this 100 times bigger in order to become a 75. So you can multiply by 100 both sides, and then you're going to change your algorithm to be 375 divided with 75. How many 75s are in 375? So now let's do the standard algorithm. 75, 375. This is good to prove your answer. If I have 75 here, that's 1. Then if I have 75 again, that's 2. 5 plus 5 is 10. Remember 1, that's 150. I'm adding 75 again. That's 3. Okay, plus. So 5, 7, and 5 more makes 12. Remember 1 more, that's 225. If I add 75 more, that would be, remember 1, 0, 300. That would be number 4. And if I add 75 again, that will make me 375. So I prove. Okay, I'm gonna leave. Oh, sorry, I wanna make a little bit bigger for you so you can see. So we we change the fraction into decimal, and then we use the rule about the if I need to have the divisor to be whole number, I need to multiply by 100 both sides in order to have, so then our equation becomes 375 divided into 75s. Then we think about how many times we can think. If we go, there is, if you have 300, you cannot make a group of 75. If you have 37, you can, but you can make groups of 75 into 375. So we add 75 once, twice, 3 times, 4 times, 5 times to get to 375. So our answer is 5. So 5 times 75 is 375. When you subtract, you have no remainder. So we prove our answer to be correct. I also want to explain how I got this to the match with the picture. So if you don't want to draw a picture, you can think, okay, 3 holes. If I cut them into the fourths, these 3 holes, they will make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fourths. So 3 holes, let's see here, are 12 fourths plus the 3 fourths that you had. Together, that would be a 15 fourths. When you think about this, you can now apply this into the, you will have a 15 fourths divided in groups of 3 fourths. So right now, you're thinking about having group of fractions that are 15 fourths, and then you're going to group them into groups of 3 fourths. So you can make 5 groups of. We can go back into the 4th grade thinking how you can divide 15 fourths into the groups of 3 fourths, and that is a picture right here. Look, so what that means, I'm going to make 3 fourths plus these 3 fourths plus these 3 fourths plus these 3 fourths plus these 3 fourths. So I am sharing these 15 fourths into groups of 3 fourths. So then finally I have 5 groups of 3 fourths. Okay, so I hope that makes sense to you and it helps. All right, I think I need one. Okay, I can make it smaller so you can see it all. Okay, so this was a lesson 10 word problem, and we solve in the 2 ways. I'm just gonna clean this because I don't like when I make mistake. All right, I do it. All right. Thank you guys. Thank you for listening. That was Mrs. Z, and it was lesson 10, grade 5, mission 6. Okay. Bye-bye.